Hello and welcome. We're going to be talking about linear measure today, which is section 1.2 in our book. You should already have done the warm-up here. That will be graded as our notes. I will not walk through that unless you are in class. You can ask questions if you need it. Our essential questions today are how can I apply segment addition, as well as how do I construct segments that are congruent. Even before that, we're going to do some quick measurement tools such as a ruler with inches and centimeters, and then we're going to do segment addition and do a construction of congruency. So the first thing is we're going to move up here, and remember our highlighting things. We're going to highlight example 1 in blue. If it's an example, we're going to highlight it in blue. So now what we're going to do is we're going to use a ruler to find the length of the pencil. We're going to write our answer to the nearest inch, to the nearest half inch, and the nearest quarter inch. So I'm going to bring up a ruler. So this right here is a ruler that has inches from 0 to 6. And we're going to start with the 0 all the way right here and put it right on those lines and look at that. So we have 0 inches, 1 inch, all the way up close to 2 inches. So to the nearest inch, it's closer to 2 inches than it is to 1 inch. So we're going to go ahead and write 2 inches. Now, to the nearest half inch, the half inch is in the middle of this. So 1 to 2, the middle, 1.5 is right here. So is it closer to this or is it closer to this? Well, it's closer to this middle mark, which is 1 1/2 inch. So we're going to write 1 1/2 inch. So the nearest quarter then is broken into quarters. So we have 1. This is right here is a quarter here, another quarter. They're the next tick mark here. So if you see those three a little bit larger tick marks, then those small ones are different. So the biggest one are the inches, then it goes to quarter inches, and then it goes to eighths right there. So it'd be 1, 1 1/4, 1 1/2, or 1 2/4, and then 1 3/4, and then 2. So is it closer to 1 3/4 or 1 1/2? Well, this line here is closer to right here, which is 1 3/4. Again, 1/4, 2/4, 3/4. So we're going to write 1 3/4 of an inch. So what I would like you to do is pause it and try it yourself for this toothpick right here, which it's hard for you to do in this, but let's just put this right here. I'll put it right there so that you don't have to measure it. You just have to set this here and look at what those would be. So pause it, try to find those answers. Hopefully you tried this. Just notice that I should have put ES, inches, 1 1/2 inches for both these top ones here. Just some things that are English-like. But this is 1 inch. It's closer to 1 inch than it is to over there, which is 2. It can either be 1 inch here or it's going to be 1 1/2 inches. Well, it's closer to the 1 1/2. And then it's closer to here, which is 1 1/4 inches. So let's go ahead and try another example. Oh, sorry, before we do that, our check your understanding ones, we should always highlight those. We're going to highlight all of those in orange. So then we still need this one in blue, but then we have to have our check your understanding. We're going to do those all in orange. Okay, so let's go ahead and move this up and do the same things, except we're going to not use inches anymore. We're going to throw that away. We're going to be using centimeters now, which, if I think about it, this is this right here. So centimeters and millimeters, we'll be using this kind of a ruler, which cm represents the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, from 0 to 1 is a centimeter. Now, there are 10 millimeters from 0 to 1. So millimeters and centimeters and the metric system are very, very nice because it all deals with powers of 10 or multiples of 10 and powers of 10, like if you want to think of it that way. So what we're going to do is we're going to measure this pencil. So again, you put that like here. Again, you line up this red line right onto this area here, and we're going to measure all the way out to here. So to the nearest centimeter, well, we have 1, 2, 3, 4. Is it closer to 4 or is it closer to 5? Because this is in between 4 and 5. Which one's it closer? Well, It is indeed closer to 4 centimeters here. So we're going to write down 4 centimeters. Now, is it going to be closer to how many millimeters? So let's figure out how many millimeters it will be. Again, this will be like 10, 20, 30, 40 millimeters, and then we have to count 1, 2, 3. It's about 3 millimeters there. So it'll be 40 plus 3, or 43 millimeters. Again, this millimeter is mm, and this centimeter is cm for your sake. So now I would like you to check your understanding, and we'll put this right here for you and try to do that. This is a little bit interesting just because it's off a little bit, I get it, but go ahead and see where this would be for both centimeters and millimeters here. Pause it and I'll have an answer shortly. I hope that you would have got 3 centimeters and about 34 millimeters. Again, using this versus the actual thing is a little bit off, but it should be pretty good. Okay, now we're going to talk about segment addition, the last thing on this page, and then we're going to actually apply it on the next page. So first off, highlight in green because it is a new vocab term. So we're going to edit this definition a little bit. I think I want to make it a little bit better. So if we have P, M, and Q, we have P, M, and Q, and we're going to say they are collinear on the same line. So collinear. Again, that is a term we learned yesterday or the other lesson, which means on the same line. And we're going to say M is not in the middle. We're going to say in between. And we're going to say P and Q. Then what we're going to say is that we have this length here of PM, which is right here. We have this length of MQ is going to actually be added together to get this entire length here. So PQ is going to be equal to that PM plus that MQ. The idea is that we can take PQ and break it into 2 little parts. And this is what we would demonstrate with a spaghetti noodle, but we are not in class right now, so we can talk about that later if you need help on that. So let's go ahead and flip it to the next page.